Problem number 22. Create an equation of a function without parentheses with a whole at x equals 2, a 0 at x equals 5, and a vertical asymptote at x equals negative 3. So the first thing, if we are going to have a function, we do want to start with f of x, and I think that's why some of you on the exam got some points off on it. Okay, I'm going to make a fraction because we are going to have some discontinuities. We know we want a whole at x equals 2. So we want a removable discontinuity at x equals 2. So if I put x minus 2 on the numerator and denominator, those two will cancel out and create a whole. So we got that set. A 0 at x equals 5. Well, a 0 means the equation is going to equal 0. So that would be, we would want the numerator to equal 0. So if we put x minus 5 in the numerator, that would cause the equation to equal 0. So we are set on our 0 now. I think that was one of the biggest mistakes on the exam. Vertical asymptote at x equals negative 3, which means there is a non-removable discontinuity at x equals 3. So if I put x plus 3 in the denominator, there's nothing that's going to cancel out with that. So now from here, all we need to do is just factor it or FOIL it out. So in the numerator, we're going to get x squared minus 7x plus 10. In the denominator, we're going to get x squared plus x minus 6, and there is our function, and it does say f of x. Okay, 23. A particle moves along the x-axis so that its velocity at any time t greater than or equal to 0 is given by the velocity formula. At t equals 0, the particle is at x equals 3. Find the values of t for which the particle is at rest, and how do you know the particle is at rest? All right, if the particle is at rest, it is not moving, which would mean the velocity will equal 0. Please notice that they already gave us a velocity formula, so all we need to do is simply take that velocity formula and set it equal to 0. And now I am going to factor it to t. I'm going to use the magic number trick as I do this. I'll be looking for negative 30. And that would be negative 6 and positive 5. This first one I'll divide the 2 out of, so I'll get t minus 3, and t equals negative 5 halves. And when we do this, the t equals negative 5 halves, well, no, it's not. It's still 2t plus 5. Sorry, I went one step too far. Now we're still setting it equal to 0, so t is going to equal 3, and t will equal, if I subtract 5 and divide by 2, I'll get negative 5 halves. All right, since t is greater than or equal to 0, we don't have to consider time being a negative. So time equals 3 is when the particle is at rest. And the question says, how do I know that the particle is at rest? And the reason is the velocity is 0. It is not moving. Okay, notice there was an extra bit of information in this problem which dealt with where the particle was at t equals 0, and we didn't really care about that. Okay, 24. Oh, somehow I skipped that one, but we'll just put it over here in the corner so I don't have to redo this video. Okay, this one said, same setup for the question, for what values of t does the particle move to the left, and for what values of particles of t does the particle move to the right? Okay, again, we're talking about movement, so that's velocity. So to figure out where I'm going to the left and right, I'm going to make a velocity chart. Notice it's not an f prime chart because we're talking about velocity, and nowhere in this problem does it ever mention the function f. So we do want to do a velocity chart, and I know that was the issue for some of you. And then the only place where we found out the velocity was equal to 0 was at 3. So if I plug 2 into the velocity formula, I will get a negative number, and if I plug 4 into the velocity equation, I will get a positive number. So the particle is moving to the left from 0 to 3, and the biggest thing here, it's not from negative infinity to 3, because t has to be greater than or equal to 0, and that would be because, not f prime, but because velocity is negative. And then the particle is moving to the right from 3 to infinity, and that would be because the velocity is positive. Okay, 25. Find all horizontal asymptotes. Justify your answer using calculus terms. So we definitely want to talk about limits when we do this. If none exist, explain why. Right, when we're finding horizontal asymptotes, we first of all want to find an end behavior model for the function. So an end behavior model, remember what we're going to do is take the highest power term in the numerator and the highest power term in the denominator. So we'll get 5x squared over 3x squared. That will reduce to 5/3. Okay, once we found our end behavior model, now we're going to find the limit as x approaches infinity. And you'll notice the limit as x approaches infinity, there's no place to plug the x in, so my limit will simply be 5/3. And whatever my limit is, that's going to be my horizontal asymptote. And my horizontal asymptote is a y equals equation, so my horizontal asymptote is going to be 5/3. And then it says to justify your answer, y equals 5/3 is a horizontal asymptote because we found that the limit as x approaches infinity was equal to 5/3. So that's what we would be looking at on that problem.